sufficient, or I need to know EMR?
No, Glue will actually help you.
Okay.
EMR is not ever used. Glue is something that is used. Actually, see, the actual work that you do is same on EMR and Glue. It's just that platform is different.
Okay. So mostly so mostly how the resume gets shortlisted, which is a skill is an important skill set.
It depends on what the GD is. Okay, so I'll say Lambda functions, AWS Glue, S3. If you know EMR, that is well. Databricks and one of the data warehouse, Snowflake or Redshift. This much is sufficient.
Sufficient. Okay. And also, see, now we can connect the cloud Snowflake with an Visual Studio, this thing. So in real time also we'll be using the same thing, like installing the plugins and connecting, doing the select query in Visual Studio for Snowflake.
No. It's only on the Snowflake console, not connecting the Snowflake actually.
Okay. And also like scheduling the job, right? We'll be using that AWS that MMA Airflow, something is there, right? No,
in AWS Glue, in AWS Glue, do you have its own scheduler? See, Airflow is needed when you have, variety of technologies, okay? Like you are working on Hadoop servers and you want to start your Spark job, you want to start your Python code, you want to start your Hive query, you want to start your Scoop job, okay? In those scenarios, in those use cases, Airflow is something practical.
Okay.
If you are on just cloud, if you are using cloud-related technologies, Airflow is nowhere used.
Airflow, it's not like an Airflow, managed workflow. Something is there in a cloud, AWS, right? Managed workflow.
That is actually just, you can pick the jobs, like which job you want to run when.
Okay. Yeah, that is similar to Airflow only, right? Actually, that's Airflow, I think, but
it's more advanced, okay? Airflow is actually more advanced.
No.
Managed workflow is in Glue is just allowing you to select Glue jobs, crawlers, and that's all. Airflow, as I mentioned, it allows you to connect with various of technologies. It can do some bit of Python runs as well.
Okay.
Airflow is actually a bit more advanced. It's a complete different scenario. So mostly you'll find Airflows used in data engineering projects, but not in cloud. It's mostly other places. Okay, then let's start because it's already, I have waited for 5-6 minutes now. Okay, so we were on Redshift. Okay, so yesterday we have seen Redshift's architecture, and we have already seen Redshift's some features and distribution style. That is the most important thing. Then we have Redshift short keys. Okay, so actually, I mean, if you see the create table statement in Redshift, so I mean, it's mostly like normal syntax only. What is this example? Why do not I have see the example? If you see this example, create table, okay, it's a very generic create table statement till here.
Your screen is not shared.
Okay, so if you see this example, this is like a very generic example of creating a table in any database or data warehouse systems. Here we are mentioning the column name, its type, and not null constraint. Okay. Now, if you see, we are also mentioning the primary key and foreign key. Understand this thing. You can mention this table, things in Redshift, but they actually doesn't exist. Okay. So then, if you see, we are also mentioning dist key. Okay. This means I am saying list ID is the distribution key for my table. So using the list ID, we have distributed data using a key distribution. Okay. And then I'm mentioning the key compound short key, that means list ID and seller ID. So basically in Redshift, we have two kind of short keys, okay? So that basically means, I'll open this Excel. See, while you create a Redshift table, you can choose the sorting style. So when the data is getting copied into your table, okay, this is not the sorting while you select the results or while you write a select query, that is order by, okay, do not get confused. So while we copy data into Redshift table, at that time, Redshift is going to store the data on its compute nodes. So how it is stored, that is what we are actually talking about. And how it is going to sort this data, that we can decide here, okay? We can give the sorting keys based on those, it's going to decide. So we have two styles. First one is compound. Okay. If I say in easy words, compound short key basically means when you use two or more than two columns to combinedly sort your table, and those columns have relationships like in hierarchical relationship if they have, then you will use compound short keys. Okay. If I give you some examples like country and a state and then city. So you can use these three columns as a compound short key columns, okay? Because if I'm storing my data, let's say India, then let's say state is Karnataka, let's say city is Bangalore, okay? And let's assume that we have multiple rows here. So it will actually have this knowledge, okay? It will create such indexes and it will optimize behind the scenes in a way that when you search for something in Bangalore, it's going to utilize the sorting as well, and it's going to filter out the most of the results without scanning those. So it will have the idea that Bangalore is some value that is only associated with the Karnataka state, and it is only associated with the country of India. Okay, so this is how it's actually going to help your queries. Okay, so if you use compound short key, then other one is interleaved. This is this is a sorting you use when you want to use two or more than two columns to sort your data, and those columns have no relation at all. Okay, so maybe you are sorting this first you are sorting based on some amount, and then let's say you're sorting based on color. Okay, so these things have no very expressive relations between these things. So in such scenarios, you are going to use interleaved short keys. Okay, so this is going to be something like this. You will say the like this is where your columns end. Then you mention the dist key, that is your description style. I mean, if you mention this dist key, by default, Redshift will understand that your description style is going to be uh, key distribution, and the key for that thing is list ID. Then if you see, this is it is also mentioning the sorting style. The sorting style for this table is going to be compound short key. So we will say list ID and seller ID here. Okay. So if you see example, I mean, I don't know what data they're showing. Basically, they are showing data. Okay. So this is how we actually define the things here. So these two things, again, I'm repeating, your description styles and your sorting styles actually help you to optimize Redshift queries. Okay. So if you are using these columns very frequently in your filters, group by or join clause, that means again, if these columns are dominating your SQL queries, if you use these columns intelligently in your sorting style, then it will help you to optimize your query. That means the queries will run faster. So if you have any questions.
Jalaji, the disk key, right? It's kind of a distinct values. It will show the only distinct values, right?
No, dist key is not distinct values, it's distribution key.
Okay.
So if you see more examples here, you can see here create a table with even distribution. So this is the example, create table, and you say distance style even, okay, and then it says create table with all distribution. Then you will simply say distance style equals to all, and in the case of create table with a key distribution, you simply have to say it says create a table with distribution key, a compound short key, and compression. Then you have to say something like this. If you are using interleaved short key, you will simply use a keyword interleaved. That's all. And we can see in this example, customer, key, city, and market segment is like completely 3 different columns, and that's why they are using a interleaved short key style for this. And if you see the example of compound short key, okay, this is the example of compound short key. Okay, this is the example of compound short key. The first one itself. Here list ID and seller ID might be related. They are saying that these things are related.
No, we are using a primary key, foreign key, those kind of things, right? So it will be coming like an OLTP only, right?
No, actually what happens now, if I'm not wrong, what happens in these data warehouses, you can mention this thing. Okay, so if you read this table definition, as a developer, you will understand that your sales ID is something, it's your primary key for your table. But if you try to upload data into this table which have duplicate sales ID, it will accept it.
Oh.
It is just for your reference. It is just for your reference. That's all. This you can say kind of commented thing or kind of meta information about your table. So as you can see, primary key and foreign key constraint are also defined in table. But prior to creating the table in the example, you might need to add a unique constraint to each column that you're trying to refer by foreign key or primary key. By default, it will not be there. Okay, so let's do one thing. Let's log in into AWS. So one thing I'm going to do, I'm going to resume my cluster. Okay. This will invalid cluster state. It's not going to allow me. Resume now. If I click this. Okay, it's modifying, so we are good. Yeah. So what you guys can do, you can click on create cluster. Choose a cluster name. You can choose, by default name as well. For you guys, if you have created the account, in like If it's not more than 2 months old, you will get an option here to choose free trial. Please choose that, do not pay. If you're not getting it, something like this, you will get choose node type as DC2 large, choose number of nodes 1. Okay. Come down if you want to practice, load sample data, choose username and password. Okay. Choose a IAM role. This IAM role needs Redshift full access and S3 full access to policies. Okay, choose a IAM role, and that's all. Do not need no need to touch any network or security configurations. Simply click on create cluster. Okay, creation of the cluster will take around 10 to 15 minutes of time. Once you do that, you are good to go. And also, even if you are on the free trial, make sure you pause the cluster. Okay, so if you come on this page of clusters, you will find the option here. If you choose the cluster that you have created, you will find the option of pause, resume, and all those options you will find. Once you pause the cluster, your data will remain intact. No tables, no data will be dropped or get modified. Only thing is that you will not be able to run any queries over that, and also you are not going to pay anything for that. Okay, so keep your cluster in pause state if you are even if you're on free trial, and if you are on paid version, then for sure you have to make sure you pause it. Okay, do not keep it open. That is the whole thing I'm trying to say. So once this cluster gets resumed, I'll just show you how to load the data into Redshift. So basically, it is fairly easy. Okay, so we just have to create a table. Okay, I'm creating a simple table. See, it is not mandatory to always mention the data description style or the short style. Okay, if you do not know those things, you can create a table as simple as this also. So I'm going to create a table, and I'm going to run the copy command. So here we no need to create any stages, file format, all those things. Sorry, because Redshift and S3 can be connected natively. All you have to say is like copy table name in which you want to copy from basically the location where your data is stored on S3. IAM role it has to assume while running the copy command. This should have Redshift full access and S3 full access, and you mentioned the format is CSV. That's all you have to mention, and you will be able to load the data. For by default, Redshift expects Parquet file format. So if you have Parquet file, then you have to just skip the line number 29 from this. Run these 3 lines. Okay, then your code will work as smooth. It will work actually perfectly. So Redshift is actually kind of simple in these things. You no need to worry about the integration objects, snow pipe, stages, file formats, and in the case of Parquet file that you upload, so you no need to extract the data from the JSONs. It's very fairly simple. So let's just re-verify if the cluster is available. It is available now. So you can click on query editor. Click on connect to database. So until unless you modify any connection, I mean, if I go back on the same screen, until unless you modify the connection, you have to just say choose a cluster in the from the drop down. Type database name as dev. Type user as AWS user, all small caps. Okay. Then simply say connect, and it will connect for you. So once you have this thing, let me just refresh this thing. Okay, so you can see I already have my data that was already there. So I'm simply going to copy this table. Simply going to create this table sales data. Let's create _2. Fail. Okay, sales data 2 is now actually created. Next thing is, if you see, I have the data on my S3 bucket. Okay, I have this file with me. Okay, so if I use this copy command and run it, sorry, my bad. I have to say copy sales data _2. Okay, so this copy is finished, and if I do select star, this is the data that we have uploaded. Okay, so see, I mean, eventually, if you want to write Redshift on your CV, all you have to understand about Redshift's feature, then your work is going to be SQL only. Okay, it is nothing different than your MySQL DB or PostgreSQL. So if you know SQL, very confidently you can mention this on your CV. After knowing all this distribution style, short key style, and all those things, few more things I'm going to cover. Once you do those things, you can definitely mention the Redshift on your resume. So all the concepts like SQLs and all those things are actually same here. So if you have any questions, you can let me know.
So in Redshift, right? We don't like a store position, right? Like in a Snowflake, we have store procedures. So in
same thing is actually here. So if you have, you can create UDF examples for you. You can create a functions. You can create procedures for you.
Oh, okay.
Like if you see the example of this one, it is generating the Fibonacci series. I created simple examples. Let's create Fibonacci 2. And let's call the same thing Fibonacci 2. So we can, I mean, those things actually there. I mean, you can create any logic. I mean, you can write any logic inside the procedures that you want.
What is the $$ language actually?
You are saying this procedure is following PL SQL. That is, your procedure is expecting SQL syntax. Okay, so if you see this example, this is Python. So it's kind of Python syntax we are writing, like if A is equal to greater than B, and here if select case when. This is SQL example. This is Python example. Like these two functions are actually same thing, doing same thing, but this is in Python. This is in SQL.
Okay.
Okay. In that case, there's one more thing in Redshift that is called Redshift Spectrum. See, as I have told you, last class, that let's say we get 160 GB of data storage for one single node. Okay, and let's say there is some data that we want to join with our table that exists on Redshift. Okay, let's assume that there is some data on S3 service or on other some other service like such as RDS or some SQL database. Okay, is there, and we have some data on Redshift, and we want to join these two tables, or we want to query the data that is not on Redshift but on S3. Okay, in those cases you can use the service called Redshift Spectrum. This service allows you to connect with external storage or external metadatabase storage to query the data on Redshift. Okay, so if you see it practically, here I'm creating a table called, no, wait, not this one. Yeah, here I'm connecting. Okay, if I take this example, here I am connecting. I'm creating an external schema called glue catalog DB. So what is going to happen right now? I just have one public schema. Okay, I have glue catalog DB. So let's create something else. Actually, glue catalog DB underscore 2. Okay, I'll create this schema. Okay, so it is going to be reflected here in this Redshift database. I am creating this from data catalog. Data catalog basically means glues data catalog. Okay, and then I am saying connect to database glue catalog DB. So let's go on glue actually. Okay, so here if I come on databases, this is the database name that I have to mention there. So I will just let's connect with DemoDB. Okay, any database actually will work. Let's connect with example DB. I mean, anything is actually fine. So I'm connecting my example DB, and that example DB I'll call it example DB only. Okay, let's just call the same thing example DB. Okay, I'll just say a spectrum. I am saying use this IAM role. Okay, this IAM role now should have Redshift full access, S3 full access, and AWS Glue console access. Okay, so it can access the AWS Glue's data catalog. And I am saying create this external database if it does not exist. Okay, so if I execute this query, it is created. Now if I go here, I'll get example DB spectrum with me. And I have those 3 tables which are present under my example DB on data catalog: test countries, test spec CTL, and test regions. Okay. If I come back here, let's try to do a preview data here. You can see I have my data visible here on AWS Redshift. Okay. So what we are doing here, we are using the power of AWS Redshift Spectrum to query the data which is present on S3, but with the compute capacity of AWS Redshift. Okay, this sort of approach is suitable only for ad hoc queries. It is only suggested for ad hoc queries. Okay, just in case once or twice in a month, if you want to join or these tables, or if you want to query these tables on Redshift, you can do this. Okay, so again, you are not supposed to create external schemas for those tables that you want to query daily. In those cases, it is recommended to move the data on Redshift itself. Okay, so yes, this is one more feature of Redshift, that is Redshift Spectrum. This can be asked in the interviews. Okay, so they will definitely not ask this directly, like what is Redshift Spectrum. They will give you the same thing. Okay, they might say to you that we have some data on S3 and I want to query this, and we are not allowed to use Athena or something. Some stories they will formulate, and see, it's very simple. If they say data is on S3 and they want to query it on Redshift without moving it onto Redshift, only solution is Redshift Spectrum. So yes, if you have any questions.
So in Redshift Spectrum, we are not actually storing the data. We are just creating an Excel schema and querying it here, right, in Redshift. So can we
Yes.
apply the same for other data also, not just the one in S3?
I think Redshift Spectrum connects to variety of sources. Yes, we can do that.
Okay, and that data could be anything, right? Structure.
What do you mean by anything in the data? Hello. What do you mean by anything in the data, Ashwarya?
As in like transactional data. In my
This is
project,
break.
we
Can you please repeat yourself? Maybe you can type your question. If you're not, you can type your question and send it to me. Okay. In that case, let's move ahead. Please, please draft your question into chat box. I'll answer that. Okay. So. Just give me a second now. Yes. So see, first thing. Now, how does Redshift creates backups? Okay. So there's nothing like time travel in the Redshift. All you can do, you can create a point in time recovery in Redshift. Okay. So it is not storing all the changes, but it can store the changes. Okay. So what you can do, if you come back on Redshift, okay, if you go on this cluster, inside this cluster information, okay, if you click on actions, you can say create snapshot. Okay, snapshot is nothing on it's just creating the backup of your table. So in this case, all the tables of your Redshift cluster will be saved on this time and like this date and this time. Okay, so if something goes wrong, you can restore the table. Okay, so if you click on click create snapshot, you can give a proper name here, like this is the snapshot and it is taken on this date and time, and you can see the retention period of this snapshot. So you can say store it for 7 days, store it for 1 day, or store it for indefinitely. Okay, you can choose the snapshot's duration as per your choices. Okay, otherwise I think there's somewhere we can automate this as well. Definitely, as you can see, you can schedule the queries, you can save the queries, and you can schedule the queries. You can pause and resume the schedules. Okay, that means you can provide a time, like at this time you want to schedule and restart the servers. It is not like Snowflake. So right now I'm not querying my data, and my server is not going to get a pause. Okay, by default. It's going to keep running until if I'm querying or not, it's going to keep charging me. Okay. There is one place where we can automate the schedule, automate the backups. Actually, that's what I'm trying to say. Create snapshot is fine, but I want, this is like manual snapshot. I definitely can create automatic snapshots. That is going to take, yeah, here it is, backup details. You can edit this. You can say how many snapshots you want to take, or how many days you want to retain this. Okay, and then it's going to create snapshots for you automatically on schedule basis. This is about backup of Redshift. It is not as good as Snowflake, I'll say. It is there, but it is not as good as Snowflake. Like you cannot go on each and every seconds of like Snowflake. Then this query editor version 2 as well. You can try this. It's actually more advanced than your query version, like normal query editor that I have shown to you. You can actually try to explore this. You can apply limit, and you can say explain. You can say isolated sessions, cluster, what you want to choose, your tables. You can connect to multiple clusters here. Like you can load the data from CSV like we do in our Snowflake. This load data is not going to connect with S3. It is going to connect with your local machine. Okay, you can choose S3 file location, or you can choose. You can choose here load from local file. Okay, or you can choose from load from S3 bucket. You can start notebooks here. Okay, you can start notebooks here to query the data and do some activity with the data. Again, it's nothing different. It's just the queries you have to write here. Okay, then if I come back here, one thing I was more interested where it is configurations. Okay, in the configurations, you have this thing called workload management. This is again one important topic in the Redshift. So by default in Redshift, you get a parameter group like this one. You have default Redshift 1.0. This is always you're going to get in the Redshift cluster. If you choose this, it provides some set parameters for you first of all. Okay. like auto analyze is true, auto MV is true, date style is ISO month, date and year format. Some small confusions are there. These configurations you cannot change it, and it is also advised by Redshift or AWS to do not change this confusion until unless you have very specific use case. Okay. But if you have some different use case, if you want to modify these configurations, you'll have to create a new parameter group. It's fairly easy. Just simply click on create and give a name and description and click on create. Once you do that, you will get something like this demo. Okay. Here again, you can modify the parameters on the default Redshift. You cannot modify anything, but on your created one, you can modify it. But most important thing here is the workload management. Okay. Now, by default, workload management is running automatically on your Redshift cluster. Okay. It's going to run automatically on your Redshift cluster. But in customized mode, what you can do, let's assume that you are working in a project where you run some analytical queries, and those queries runs almost for 8 hours, 10 hours, 12 hours like that. Okay. And mostly all those queries are running parallelly. So let's say you run 20 such queries parallelly. Those are going to run for 8 hours, and those are taking all the resources of your Redshift cluster's compute capacity. Okay. In that case, what's going to happen? Let's say some of your developer or someone in your team wanted to run some query that was supposed to be finished in 5 minutes. But what will happen, as there's no capacity left, it's going to stuck behind in the queue. Okay. So it will have to wait until unless one of the query of those 20 queries is going to complete and they free up the resources. So sometimes this situation might not be a good scenarios. Okay. So what we can do in this thing, we can switch to customized WLM mode. We can create something. We can create something like WLM workload management, and we can click on edit workload queues. We can say Q1. We can say allocate 70% of total memory, and concurrently you can say let's say run 10 queries all concurrently. Okay. You can run timeout and all the settings you can actually all fix it again, and you can create multiple queues like that. You can see, okay, you can say query 1, query 2 like that. Okay. So if I say practically it should be like long queries, short queries. So you will create a query group that will name as long queries, allocate 70% of memory. So you are saying, okay, now those 20 queries which were supposed to take 10 hours, I'll run them on this query group. So now as they have 70% of memory, they might run for 12 hours instead of 10 hours. But I'll keep my 30% of memory for my short queries. And so if in case if I want to run some short query, those have some memory to execute and finish early, like in 5-10 minutes for me. Okay. So I'll not have to wait for 10 hours to finish the long queries before I start my short query. So this is what workload management in Redshift is. Okay. This is something you should know theoretically. Do not try to practice this because this is not your job. It is admin's activities. Okay, mostly you will not get any access to Redshift's configurations because this is an administrator. Like I'm the admin of this account. That's why I'm able to do all these things. So I have the access, but in real-time projects, you will chances are that you will not have this access. Okay, so again, I'm repeating, this is important to understand what is workload management, how it is actually is done. Okay, you can give this example of scenario-based example, like when it should be used. Okay, but it is not your responsibility to configure this. Okay, you can clearly say, I know about this, I can do it. Okay, you just say I can do it because nobody is going to do it actually. Okay, but let's say we had a admin and those team were doing it for us. So if you have any questions about workload management, you can ask me. Okay. In case if you have no questions, let's move ahead. Then in Redshift, we have something called analyze option. Okay. So see, if you see this option of configuration, it's called. This the parameters, the first option, auto analyze equals to true. So this is something is as per the Redshift documentation is implemented in 2018. Before this, what were happening in Redshift clusters? Let's say you upload 1 GB of data in 1 GB of data today in Redshift cluster. Okay, and you choose some short keys for that. So based on those short keys, your data is going to be completely shorted before it gets stored in the table. Okay. On day 2 also, when you execute this copy command to upload the new set of data into same table, that set of data is also going to be completely shorted. But the day 1 data and day 2 data are not going to be completely shorted. So what I'm trying to say here is something like this is going to happen. Let's say we have day 1 data. Okay, this is going to be like 10, okay, 11, let's say 14, let's say 60, let's say 19 and 20. Okay, let's say we upload day 2 data. Let's assume this has 2, 5, 10, 15, or no, let's say we have it's like 10, 10, 15 and 18. So what Redshift is going to do, this data will be shorted and it will be appended in the table. This data is also going to be shorted and it will be appended into the table. So both the base data is sorted, but not the complete data is shorted. Okay. And after multiple days, this might start causing slowness in your queries. So admins at that time had to run the command auto analyze. Okay. They had to run the command of, and they had to run the analyze command to fix this issue and reshort the complete data in Redshift. Okay. Same way, let's say you delete these 3 rows. So what Redshift will do, it will not delete these 3 rows, or it will not purge the data from Redshift storage. It will simply archive this. Okay. So it will Redshift will mark these rows for deletion, but it will not mark. It will not free up the memory for this data. It's only going to do this when you run the analyze command. So previously, this was also a hot question in the Redshift interview, like in how many days you should do run analyze a command, or after how many days you should reshort your data or rearrange your data. But nowadays we have auto analyze equals to true. So by default, Redshift is going to take care of this thing behind the scenes for you. You don't have to worry about this. But again, this might be asked in interviews. Okay. So if I show you, this is we have what we had talked, parameters group, workload management, vacuum. Okay, so vacuum is the command that we had to run before the auto analyze equals to true. It reshorts the rows and reclaims the space in either specified table or all the tables in the current database. So if you see the examples of vacuum on internet, so this is like vacuum sales. This is like, vacuuming the sales table. So it will reshort the data and it will also reclaim the space if there's any. Okay. This is like vacuum sales to 100%. That means you want this to be 100% shorted and 100% space claimed back. Okay. This is the example you want to do short only. That means you are saying I don't want to reclaim my space, but I only want to reshort my sales table to 75%. That means at least 75% of my data in sales table should be sorted. This is what we are trying to say here. Nowadays, these things actually are done automatically by the analyze command. So Redshift analyze command is nothing but it's going to take care of all your things behind the scenes. Then this is, I mean, delete versus truncate in Redshift. It's very easy, straightforward. If you do delete, it's not going to claim back the space. Truncate is going to do that. Okay, but yeah, if you do delete, if let's say 3 or 4 days, I'm just giving you a rough number. Whenever the analyze is run, it's going to claim back the space, even in the case of delete. Truncate, immediately the space will be there. Then we have encodings in Redshift. Okay, so if you see this example, if you see the create table example, let's get it. Create table. Okay, create table. If you see this example, for some columns, this example is mentioning the encoding type as well. Okay, like encode mostly 16, mostly 8, delta 32K, like that. It is encoding it. Okay, so what basically it means is, if I give you one example from my end, see, first thing, by default, Redshift keeps your Boolean, real, double precision data types as raw compression. Okay, it is not going to compress these data types column. For your small int, integer, big int, it's going to keep the algorithm as AG64. So basically, like while we zip some files or while we zip some data, algorithm is used to zip the data. That algorithm, how it is working, it's not shared with us. Same way, same is the scenario here. How it is actually getting worked here, it's not shared with us. So AG64 is the encoding type that we can use for this kind of data. By default, also it is applied. So you know need to write it explicitly. Okay. And same way for your string character, that is char or varchar data type, the encoding type is LZO in compression. So if I come back to this example, if this column is integer type, by default, AG64 encoding is used to store the data on Redshift cluster. Okay. Then we have some specific encoding types. Okay. So do not get confused here. Encoding is nothing but in Redshift, now what this is actually a good feature. You can encode each and every column. So you no need to mention the encoding type or the compression type on the top level of the Redshift table. Okay. You can encode every single column separately. Okay. So this integer is going to be AG64, like small int is also going to be AG64, and this is also decimal is going to be AG64. Okay. But if you have some character columns, those are going to be LZO in compressions by default. Okay. It's going to be by default. But then we have some specific compressions as well. Okay. So those are byte dict encoding. Like this is one of the example. So first of all, actually, before explaining this example, I will pause here. If you have any questions in the vacuum, analyze, the parameter groups, workload management, or this encodings. If you have any questions, please let me know.
Tilak, you're showing that auto scaling, right? So 1 to 10, if missing the data, it will be in back store somewhere. So it will work like an SCD type or how it is?
This is not SCD type. This is the data being stored on memory. It's not in your control. How it is being stored on memory, this is what we are talking about here.
Yeah. No,
So
you said
14,
19, 20, right? That will be removed, right? Or it will be like in backside.
So when you say delete these rows based on some condition or whatever it is, this is going to be removed from your table. Okay. You will never see this data in your table, but from the memory it will not get removed until analyze is executed. That will nowadays happens by default in some days.
And also, I'm showing that path, pointing to path right S3. So in that we can have multiple files, right, in that folder. So it will read all the files.
See, let's say we upload one file today, we upload the second file tomorrow, we upload third file third day. That's like, so day one's file is going to be like this. It's going to be sorted in itself, but not on table level. Day two file will be upload. It's going to be sorted in itself, but not on table level. Like the complete table is not going to be sorted. Its data is going to simply append it. It's not going to check whether what's the status or what is the values in this column previously. It's not going to check that. It's simply going to append the data.
Oh, okay. But for Snowflake, right? I read there is a thing, right? If you put the same file name, it will be loading like an delete and load only. We can't see the duplicates. If I have one file employee.txt, or first day I loaded to Snowflake, and second day I'm again I'm pasting the same file employee.txt. It won't load that file.
That we have done practically, no? So in Snowflake, I have shown you if you upload or re-upload the same file, it's not going to do that. But here I'm not talking about the same file. I'm talking about day one's file, day two's file. Okay. So file names might be different. Okay. You got this thing, na? You got this thing clearly?
Yeah. So here also that thing applies, right? Just a confirmation. So the duplicates will not load, right? The same file will not be reloaded twice.
No, it will reload. Yeah.
It will reload. Oh, okay.
Okay. So in bytecode encoding, see, it's very straightforward. Let's say this is the original data column, like in country's name, England, United States of America, Venezuela, like that. And let's say if you store this in character format, you will need 30 characters to store this. Okay. I'm in this example, actually I'm assuming that you give a size of 30 characters for this particular country's names column. So you will use 30 bytes of storage to store these values, correct? So what they say, if you use a byte encoding, by default, what Redshift will do for you, it will give the numbers to it. Like England, it will give 0, and then in that case, it will only need 1 byte of information to store the data. Same way, it will give United States of America as 1, and it will only going to use the 1 byte of information to store the value. So basically, all the distinct values will have their own compressed value number, and its size is only going to be 1 byte. Okay. So this kind of encoding you should use while we have very less distinct columns in some table that can be assigned some compressed numbers here. Like if you have too many distinct values in your column, like range they say 250 to 500. 500 is actually maximum distinct value that it should have. So if you have less than 500 distinct values, in that case you can use byte encoding for that particular column. In that case, it's going to use very less space while it stores the data on memory. So is it clear to you? And same way we have these examples of mostly, see, again, no need to memorize these encodings, okay? Like what LZO is, what AZ64 is. You need to understand this thing, that there's possibility of encoding each and every column separately. That's all you have to understand from this. If you can memorize few of the names, that is sufficient. You no need to memorize how mostly 16 is converting your data, how PyDict is converting your data, how Delta 32 is converting your data. You no need to think about on that level. See, again, I'm repeating, mostly in data engineering interviews, they are going to ask you Spark optimization techniques, AWS Glue optimization techniques, Redshift optimization techniques, Redshift features, S3 features, Python related questions, and then they might give you some practical questions like you have these two tables, write a query, write a Python code. Like that is going to be the fundamental of your interviews. So I'm just sharing the PPTs with you.
So Jalaj, I can using the Spark, right? I can read that Redshift also, right? We are connected.
Yes, yes, but that is again, you know, that is something not recommended thing.
Not recommended thing.
Yes, yes, yes.
Oh, okay. So in production, you write only SQL. You play with a SQL script only for a Redshift if it's going to be a Redshift.
I actually in my project I'm going to show you that how we can connect AWS Glue with Redshift. Okay.
Yep.
There's my cluster. So
Also,
click on this.
Showing, sorry. No, just a question, right? You're showing a notebook, right? In this Redshift notebook.
Mm-hmm.
So in that we can't write Python script. It does that notebook is only for writing the SQLs.
Actually, I have never used it, so I'll be frank that I haven't used it.
Okay.
Maybe I can see and I can come back to you.
Okay, sure.
Actually, that is something new I have seen today. Before that, I never seen that option.
Okay, because since it said new notebook, I thought okay, Jupyter, everything is formed.
I have to try that option. Actually, frankly, I haven't never seen that option. I really have to try it out.
Yeah.
Ashwarya, you had some questions. Can you please retry ask that question? Okay, can you hear me? Okay. Okay, so see Karthik, you know, and Ashwarya as well. Still, I'm not able
Yes,
to hear you.
Jalaj, can you hear me?
Okay. So see, mostly in the interviews now they test you on the basics only, like if you can write SQLs or not, because eventually whether you work on Snowflake or Redshift, you have to write SQL only. Okay, and these features can be learned in few days only, like we are learning now. You might get to use to it like in 3-4 months or 6 months max. Okay, so features can be learned. Same goes for AWS Glue. They will ask you questions on Python and PySpark. They'll ask you questions on Python and PySpark only. Okay, so because see, if you know PySpark, the same PySpark is there on Databricks, AWS Glue, Hadoop, EMR systems. It is everywhere. So your priority is not to learn AWS Glue or Databricks. Your priority is to learn PySpark. So if you know PySpark, you can claim that I know Databricks, AWS Glue, and EMRs. Everything you can claim. Yes, there is difference between AWS Glue, Databricks, and EMR. There are some features those are different, but again I'll say 70% it is PySpark only. So PySpark, SQL, one warehousing tool, and concepts of clouds like S3, IAM, Lambda functions, Glue, DynamoDB. If you know these things, you're good to go in market. Okay, if you have no questions, then we can wrap it up for today.
Yeah. Thanks.
Ashwarya, maybe you can type out your questions on WhatsApp or you can ping me on Skype. Okay, but please feel free to ask a question.
Sure,
Okay,
Jalaj.
thank you guys. Bye bye.